Hi, this is Keenan Casey for TutsPlus.com. In this lesson, we're going to be looking at the Hypertext Transfer Protocol, the protocol that runs the web. As you know, the web is awesome. It's been a huge application that has dominated the internet. In fact, the web is so popular that it's really synonymous with the internet, when in fact, the web is just one application that runs on top of this global network of networks we call the internet. We're going to look at four different aspects of HTTP. HTTP is a stateless protocol. That means it doesn't keep state on either end. It's a text-based protocol. That means it's easy to read. It's really just ASCII text. It's a client-server protocol that operates using a request-response model. Let's jump into this and look at an overview of how HTTP works and some of the nuances of the protocol. First, recall that it is a stateless protocol. That means that every request is an independent transaction. The server doesn't remember information about ongoing sessions or past sessions. The advantage of this is it greatly simplifies the implementation of the server, and it makes it more robust in the case of failures. There's no inconsistent state to deal with if the client or the server dies. Secondly, HTTP is text-based. What that means is the messages are written in plain ASCII text. It's really simple to read and write HTTP messages. Thirdly, HTTP is a client-server protocol. That means that there are very clearly defined roles. There are clients who send requests to servers, and the servers respond to those requests by returning some resources in the form of a response message. Let me show you how that works using this diagram. Assume we're client 1, which is Chrome. It's going to send a request message to the web server. That message will be sent to the server. This message will typically contain the URL, the name of a resource that the server has. The server will look that up and then return it in a response message. That response message will be sent to the client. Each transaction that is a request-response pair is completely independent of the next. Client 2 may follow a similar pattern where it sends requests to the server and it gets responses back. And these responses are typically web pages or images, other types of files that are used on the web. So we've seen that HTTP is a stateless text-based protocol that operates in a client-server request-response kind of paradigm. What does an HTTP request message look like? Well, this slide explains a sample HTTP request here on the left in yellow, and it shows the structure of an HTTP request message in this color-coded diagram here. Notice the important parts of this. First, there's the method. There are several different types of methods for HTTP request messages. They'll always be GET. Other common methods are POST or PUT or DELETE or UPDATE, often used in RESTful APIs. After that, there's a space. That's what the gray means. And then the URL of the resource that we want. Really, that's the path on this server that we want. And lastly, on the first line, there is the HTTP version that looks like this, HTTP/ and then 1.1 or 1.0. Following the request line, there may be one or more header lines, and these are all optional except for the first, which specifies the host to which this message is addressed. In this case, TutsPlus.com. Header lines take the form header field name, : value. Each line ends with a character return line feed, and that's what these two characters mean. After this series of header lines, we actually have the message body, which is optional. We may or may not send information in the body of the message. This wouldn't be normal on an HTTP GET message. Notice that an HTTP request message ends with 2 character return line feeds. So the symbol, the flag that means this is the end of an HTTP message is a double character return line feed. What does an HTTP response message look like? This is what comes back after the web server receives that request message. Again, there's an example of one on the left and a diagram on the right that explains the different fields. The first thing you see is a protocol. Again, this is going to be similar to what the request message had. This status line says the protocol, a code, and then a phrase associated with that code. There are a lot of different codes that signify different things that are important to the HTTP protocol. Some of the more common ones are 200, which means OK or success. There's the 301, redirection, which means this site has permanently moved. Or there's the 404 resource not found message. These codes and phrases return some information to the browser about the state of the resource that was requested. After the status line, there may be one or more header lines. You can see here on the left things like date, the server version, the last modified date of the file, how long the file is, what type of the file. All these different possible headers give additional information about the resource being returned. After an extra carriage return line feed, the body of the message is listed. For a web page, this is typically going to be HTML content that's listed out in text form in the body of this message. Might also be a CSS file or an image or any other type of file that may be requested from a web server. The last thing I want to mention is HTTP supports something called Conditional GET. Basically, this is a caching mechanism to prevent a client from having to download a file multiple times when the file hasn't changed. Let me show you how that works. An HTTP request message may include an if modified since header line, and some date would come after this. When the server gets this HTTP request, it can check the last modified time of the resource. If the object has been modified since then it will return the resource as normal using 200 OK message, and then the body of the message will include the resource. If, however, we consider a scenario where the same request is sent, but that file has not been modified since the date, in that case, the version that the client downloaded before is up to date, it's still correct, there's no reason to send that file again. In that case, the HTTP response message can return a 304 not modified. The client can use the local version that it has cached, and this will save some resources and perhaps make the website feel faster. So this is Conditional GET, a way to implement caching in HTTP. We've been looking at HTTP. We've been in the application layer. Stay tuned for some more lectures on some other important protocols in the application layer. I'm Keenan Casey for Tuts Plus. Thanks for watching.